Dear students, today we will discuss about imperative paradigm of programming languages. So first of all, we should look at generations of programming languages from first generation up till now where we are moving. So the difference between the first generation and today's generation and the future, which has been shown over here, is that previously problems solved in an environment in which human must conform to the machine characteristics. So this means human should understand that how the machine characteristics are and it should comply to the machine characteristics. However, we are moving to this direction where problems solved in an environment in which machine conforms to the human characteristics that what humans actually need. So there are different programming paradigms, and these are basically alternative approaches to the programming process. So we want to program, and to program there could be different ways, and such ways have been highlighted in this slide, that whatever the ways we have today can be classified into these four programming paradigms: functional programming paradigm, object-oriented paradigm, imperative paradigm, and declarative paradigm. And in next modules, we will be discussing all of these paradigms in a little bit more details. And in today's module, we will be focusing on imperative paradigm, on which these are the languages have been built, starting from machine language, Fortran, COBOL, BASIC, C, Pascal, Python, Ada, and different other languages as well. So what is imperative paradigm? It is also known as procedural paradigm. This is a traditional approach of programming, and pseudocode mentioned in previous modules are the examples of imperative paradigms, where we have an algorithm and that algorithm has number of steps, and then each step is executed one after the other. So it defines the programming process to be the development of sequence of commands that, when followed, manipulate data to produce the desired results. So this is the official definition of imperative paradigm. And in imperative paradigm, we start with finding the particular algorithm. We want to invent that algorithm, or we want to, if that algorithm is already available, then we need to implement that algorithm by ourselves. So we start with finding an algorithm and then express that algorithm as sequence of steps. And we will be doing imperative programming in some of the next modules, and you will also be learning some of the languages in your BS computer science, where, for example, in the next semester you might be learning about C++ and other languages in the next semesters. So all of those are imperative paradigms, and we will be covering some of the examples of imperative paradigms on online compilers in some of the next modules. So if we summarize today's module, we have learned about generations of programming languages, from where we started and to where we want to go, and then programming paradigms, and we focused on imperative paradigms.